Hello everyone, my name is Hanshen Xiang. This is the question 5 in homework 2 of the course Probability and Stochastic Process. In this question, the customer flow at the grocery store can be viewed as a Poisson process, and the probability of the number of customer arrives in the 0 to t minutes is equals to k customers, and the probability is equal to the e to the power of minus lambda times t to and times the lambda t to the power of k and over the factorial k. And in this question, the probability that in 2 minutes at least one customer arrives equals to 0.3. So we could set the number of customer arrives is the event x, and we could use set this function as the p x 0 to t times in 0 to t times minutes equals to k is equals to this function. And in this condition, we could transmit it as the p probability of x 0 to 2 minutes and over 1 is equals to 0.3, and the probability is also equals to the 1 minus the probability of x in 2 minutes equals to 0. So there is no customer arrive, and we could compute it and equals to 0.3. And for the question 1, we want to find the lambda, and use this condition we could compute the probability of x in 2 minutes equals 0 is equals to 1 minus 0.3 is equals to 0.7, and use the function it is equal to the e to the power of lambda times 2 minutes and times lambda times 2 minutes to the 0 customers over the 0 factorial, and it's equal to the e to the power of minus 2 times lambda and times 1 is equals to 0.7. So the lambda is equal to the minus 1 over 2 line 0.7 is about 0.178. And for question 2, we want to find the probability that in t is in 3 minutes and there is no customer arrive. So we could compute the probability of the x in 3 minutes, and the k is 0, there is no customer arrive, is equals to by use the function that it is e to the power of lambda times the 3 minutes times the lambda times the 3 minutes and to the power of 0 to the factorial 0, and is equals to the e to the power of 3 lambda is equal to about 0.586. And for for the third question, we want to find the t in 10 minutes, and there are at least 2 customer arrive. So the probability x in 10 minutes equals to over the two customer arrive is equals to 1 minus the probability of x in 10 minutes equals to 0 customers arrive, and minus the probability of x in 10 minutes 0 equals to 1 customer arrive, and it is equal to we can use the function above, the e to the minus lambda in 10 minutes, and the lambda times the lambda in 10 minutes to the power of 0 customers over the 0 factorial, and minus the minus lambda 10 times 10 minutes, and times the lambda 10 minutes to the power of 1 to factorial 1, and it is equals to the 1 minus e to the power of minus 10 lambda, and minus the e to the power of minus 10 lambda, and times the 10 lambda, and it is equals to about 1 minus the 0.169 and minus the 0.300, and it's about 0.531. So for the fourth question, we want to find the in 1 minute, and there is only exactly 1 customers arrive, so we could compute the probability of x in 1 minute and only 1 customers arrive is equal to use the function e to the power of minus lambda and 1 times, and times the lambda 1 minutes to the power of 1 customers over the 1 factorial, and it's equal to the lambda times the e minus lambda, and it is equals to about 0.149. So the probability of only in 1 minute only 1 customer arrive is 0.149.